Okay, so let's discuss the extended real number system. Right now, we have already defined the real numbers. So we have the real number system. What is the extended real number system? So let's define it. It's a, well, let me write the whole thing. The extended real number system consists of R. It's R as we know it. We know it. Okay, the real field, and we add two symbols, plus infinity and minus infinity. Okay. Here we preserve the original order, and we define, so here we already have the order we had before. The only question is, with the two new symbols, what do we do? So we define that any number, any real number, is in between negative infinity and infinity. Okay, this is for all real numbers. Okay, so this is basically what we know from calculus, except this is something that it's always mentioned, that careful, infinity is not a number. So here is clear now. We are making it explicit that infinity and negative infinity are just two symbols that we are adding, but that's it. They are not numbers. Now, one important thing here. So the extended real number system is not a field. Okay. In the sense that the real numbers without plus and minus infinity, that's a field. But when we add the two symbols, that's a different story. Okay, so those are plus and minus infinity, what I was saying before, those are not numbers. But there is a convention. So we have already seen so many times operations involving plus and minus infinity. Those are not really operations, but it's a convention. Okay, if we have a real number and we add infinity, then we have infinity. Okay, if we subtract infinity, we have negative infinity. And if we divide by infinity or by minus infinity, we get 0. Okay. More conventions. If we have a positive real number, then x times plus infinity is plus infinity, and x times negative infinity is negative infinity. But if x is negative, the identity is flipped. Okay, so we multiply by plus infinity, we get negative infinity. This is as usual. And when we multiply by negative infinity, we get plus infinity. Okay, but here again, careful. As usual, things like infinity minus infinity or infinity divided by infinity are undefined. Okay, these are the type of indeterminations that we would have to sort out computing limits by L'Hopital. Okay, back in Calc 1. All right, so these are, again, let me stress this, these are not really operations, these are conventions. This is a definition we are making, okay? But that's important to remember that this is not a field. Okay, it's a field extended to something else. Now, one advantage that we have now is that once we add these two symbols, plus and minus infinity, we have that they are an upper and lower bound okay. This is for every subset of the extended real number system. Okay. What does this mean? Well, for example, let's say that we have E that is all the numbers bigger, larger than 1. Okay, so this one in the real numbers doesn't have an upper bound, but so this doesn't have an upper bound in R, but it is bounded by infinity in the extended real number system. Okay. Same thing, we can write here that the supremum of E is plus infinity if needed. Okay. And then we have similar remarks for the infimum and lower bounds. Okay.